So we're going to start at the top where it says core concept. These are just vocabulary words that we're going to use throughout this chapter, and we're just going to go over them. Some of them are familiar. For example, the first one, perpendicular bisector, just to review that word. Perpendicular, as you know, means when two lines come together to form a 90-degree angle, that's perpendicular. And then bisector is something that cuts in half. So that both sides are equal. So when we're talking about perpendicular bisector, let me zoom in. It is this line right here is the perpendicular bisector. So whatever I'm highlighting in orange and I'm highlighting the word here, that's the actual perpendicular bisector. But what the perpendicular bisector does is it is perpendicular to that line and it also bisects it, meaning both sides are the same measure. So for this to be a perpendicular bisector, it has to be perpendicular and it has to bisect. Then the next one is angle bisector. Actually, while I'm highlighting, I'll just highlight all the names. So angle bisector is this line right here. And just by definition, angle are two rays that come together at a common endpoint. And bisector, again, cuts in half. But in this sense, we're cutting the angle in half. So both sides of the angle are the same measure over here. So this angle is the same as this one. Then we have median. You've seen this word in different ways before, like the median of a road or the median of a set of numbers would be the middle. It means the same thing here, but it's specifically the middle of this segment here. The median goes from the corner to the midpoint right here. So this is midpoint of the line. There. And as you can see, because this is a midpoint, then this is the same length as this. Okay, and then next is altitude. You've definitely seen this word before. It's the height of a triangle. And altitude specifically has to be perpendicular to the base, so it has that 90-degree angle. So one way to describe altitude would be the perpendicular height. Of a triangle. It could be a trapezoid, but in this case it'll be a triangle. And then mid-segment, this is a new word here. The mid-segment in this picture is this line right here, and what makes it a mid-segment is it actually hits this line at its midpoint and this line at its midpoint as well. So this is the midpoint of that segment, and this is the midpoint as well. So therefore, this is the same length as this side, and then this is the same length as this one. Okay, so those are some keywords that you need to know. Specifically in this lesson in 6-1, we're focusing on the first two, perpendicular bisector and angle bisector. So I'm kind of moving down a little bit here, starting with 6-1, perpendicular and angle bisectors. Does everybody have those? Are you guys okay with me moving? Okay, nobody's yelling at me. Cool. Okay. So starting with this first theorem, perpendicular bisector theorem, words, I don't know, might go in one ear and out the other. So we're going to use this statement and just draw on the picture to explain exactly what it is. Okay, so with this, the first part of this before the comma, I'm going to highlight orange. And then the second part, I'm going to highlight yellow. And my yellow is running out. But we're gonna make it work. Okay, so for the first part, it says that line CP, so this line right here, is the perpendicular bisector of AB. So this line is perpendicular, meaning it makes a 90-degree angle, and it's a bisector of AB, so this side of the line is the same as this. So two things, it's perpendicular and it bisects. When that happens, then you can say that CA is equal to CB. Does anybody have an extra yellow highlighter I can borrow for this so it doesn't run out? I do. You have an extra one? That would be awesome. Okay, so CA is equal to the length of CB. You're awesome. Thank you. Appreciate it. I'll give it back. If I don't give it back, then mind me. Okay, So CA is equal to CB. Now this is called the perpendicular bisector theorem. Again, if it's perpendicular and these two are the same, then you can say that these two are the same. Another way you could prove that those two segments are the same length is from side angle side. If you notice, you have side angle side here and side angle side, meaning that these are congruent triangles, and then you could say that this segment is the same as this one. Okay, next one is the converse, kind of just the same thing but backwards. So again, the first statement we're going to use orange. It says if DA is equal to DB, then point D lies on the perpendicular bisector of AB. So DA equal to DB. So essentially an isosceles triangle. This is equal to this. Then point D lies on the perpendicular bisector. So if you were to draw an altitude or a height, it would be perpendicular, of course, but it would also bisect this line, essentially giving you two right angles, which will come in handy later on in geometry. Okay, then we're moving on to angle bisector theorem. So again, just focusing on this statement here and just drawing on the picture. First part of this, we're going to make orange. And the second part, we'll make yellow. Okay, so here it says that AD bisects the angle BAC. So this right here, angle bisector, meaning both sides of the angle are the same measure. Great. It's also saying that DB is perpendicular to BA. So this is perpendicular and this is perpendicular. If these two conditions are met, then you can say that BD is equal in length to DC. So you can say that this is the same length as this. So again, angle bisector theorem, if this is perpendicular and these two angles are the same, then these are the same. You could also use side, angle, side to prove that the triangles are congruent, but it doesn't state that. Okay, the next one, again, same thing here, focusing here. First part we'll make orange, and the second part we'll make yellow. Okay, so if DB is perpendicular to AB, right here, and DC is perpendicular to AC right here, and this segment is the same length as this one, then you can say that AD bisects this angle and these two angles are the same measure. So again, if these two things are met, you can say that this is an angle bisector. Okay, so that's it for the concept review. Now we're going to move on to the practice problems.